Welcome to The Explainer. Today, we're going to tackle a classic from the world of computer science, one with a surprisingly fun name, bubble sort. Now, it might sound kind of simple, but trust me, it's one of the absolute best ways to really get the fundamental logic of how computers can take a total mess and turn it into perfect order. So let's kick things off with a problem that, computers are solving for us all the time. When you're just faced with a jumbled mess of information, how do you even begin to sort it, right? How do you methodically put everything back in its proper place?
Okay, so imagine you've got this list of numbers right here. It's a total mess, completely out of order. And your job is pretty simple. Arrange them from smallest to largest. Seriously, where would you even start? All right, so let's dive into what's called the bubble solution. It's one of the simplest, most foundational ways to sort things. And honestly, it's a perfect way to start thinking like an algorithm.
The core idea behind bubble sort is, well, it's just beautifully simple. You're only ever looking at two items at a time, side by side, and you ask just one question. Hey, is the number on the left bigger than the one on the right? If the answer is yes, you swap them. That's it. That's the whole logic. You just do that over and over again, all the way down the list. And this is actually where the algorithm gets its cool name. See, as you keep making these passes through the list, the biggest values get pushed further and further to the end. It's kind of like bubbles of air rising to the surface of water. They literally bubble up to their correct spots. Pretty neat, huh?
Okay, so enough talk. Let's actually see this bubbling in action. We're going to walk through one complete cycle, what we call a pass, to see exactly how this thing works. So here's our jumbled list again. Remember the goal. Move the biggest numbers over to the right. We're going to start at the very beginning and just look at pairs of numbers, one after the other, moving from left to right. First up, the first two numbers, 5 and 1. Okay, is 5 greater than 1? Yep, so they're in the wrong order. We swap them. Boom. Our list now starts with 1, then 5. Okay, now we just slide over one spot and look at the next pair. That's 5 and 4. Again, 5 is bigger than 4, so they get swapped. See what's happening? That 5 is continuing its journey over to the right. And the process just keeps going. The next pair is 5 and 2. And once again, 5 is the larger one, so we do another swap. You can see the list is already starting to look a little more organized, right? All right, for our last comparison in this pass, we look at 5 and 8. Now here, 5 is less than 8. They're already in the right order, so we do nothing. No swap needed here. And look at that. That's the bubble effect, right there in action. After just one single pass, the biggest value in the whole list, the 8, has floated all the way to the end, right where it belongs. Now, of course, the algorithm would start over and do this again and again until the whole thing is sorted. So, you can see this algorithm is really straightforward. It's super easy to get your head around. But does being simple mean it's actually any good? Let's talk about the trade-offs here. So here's the deal, the big trade-off. Bubble sort is absolutely fantastic for learning because it's so simple and intuitive. But in the real world, that simplicity comes at a massive cost. Speed. I mean, it's like a snail in a world of rocket ships. For pretty much any real-world problem, it's just way too slow. Okay, so the technical reason why it's so slow is a fancy-sounding concept called quadratic time complexity. I know, that sounds super intimidating, right? But the actual idea behind it is surprisingly simple. Really, all quadratic time complexity means is this. As your list gets bigger, the amount of work the algorithm has to do grows way, way faster. So if you double the number of items you need to sort, it doesn't take twice as long. It takes more like 4 times as long. And you can imagine, for really big lists, this just becomes a total nightmare of inefficiency. Okay, so if it's so impractical, so inefficient for most things, you're probably asking a pretty fair question: why in the world do we even bother learning about bubble sort? And the answer is really simple. It's just an incredible teaching tool. Bubble sort is the perfect first step on the ladder. It shows you the absolute core logic of how so many algorithms think. You compare things and you swap them. It's that slow, simple foundation that helps us really appreciate just how clever, how complex, and how unbelievably fast the other algorithms that power our world really are. And that really leaves us with one final thought, doesn't it? If this is the simple, slow, foundational way to create order, what does a fast sort actually look like? Because understanding this humble, simple starting point
is really the key to appreciating just how ingenious and powerful those other algorithms truly are.